Good afternoon, and thank you for allowing the time to join us today. My name is Charles Scott. Welcome to this month's Civil Designer Software Open Classroom webinar. In today's Project Georeferencing webinar, I'm going to be joined by Cameron Boyle, our Software Support Manager based in Johannesburg. During Cameron's presentation today, please feel free at any stage to use the text chat service on your GoToWebinar app or web page to ask us any questions you may have. Cameron, it's been great working with you again. I'm looking forward to your webinar. Please take it away.
Thank you, Charles. Good afternoon, everybody. Welcome to today's webinar. We're going to be looking at how you move your projects. There may be different reasons why you want to move the project. I'm going to look at two options. In this first example, we got the incorrect central longitude. I'm going to show you how to fix that. And with this project, we've set it up initially using a local projection. I'll show you how to change the projection with the correct options. When you create a new project from scratch, you go to File, you select Project Settings, and then you go and select a terrain option. The reason why we create the terrain option is because we want to bring in a survey. And if I go and click on Open, click on Yes, a lot of times we find that our clients have forgotten to set up the projection settings. If you click on OK now, you're just using the default settings. And at a later stage, it may be that you've done the design and you find that you want to export this now into Google Earth. It's not geo-referenced correctly. As an example, if I go to File, Export, Export to Google Earth, I'll just do the CAD drawing, specify where you want to save it. It will automatically open up Google Earth. From this, we can see that actually our project is positioned somewhere in the desert. So we want to go and correct this. I'm going to show you how that's done. Before we do anything, there's a couple of things that you need to make provision for. Your sewer, storm, and water is easy. You don't need to make any additional changes to that. But your roads is associated with your DTM or terrain file. If I go to File, Project Settings, your roads have the same name as your DTM file. So when you create the new project in the correct geo-reference position, you don't want to rename all your roads. This particular project has 35 roads. You don't want to go and change all the road names. So instead, what I suggest you do is rename the entire project. And then at a later stage, I'll delete the DTM file and put it in the correct place. So bear with me. I'm going to go to File and select Save As. I'll just call it corrected number 1. Enter. Right, so that's the project. Now we're looking at the terrain or VT8 file. Looking at the sewer file, stormwater file, and finally the water file. So that's already going to save me time not having to rename the new files. I want to export the current surveyed information so that I can import it into the correct position with our new project. I do this still in my survey mode. I go to File, Export, ASCII. Looking at the Export ASCII file options, I can apply constants. In this case, I'm going to leave it as is and click on Next. Accept the defaults and click on Finish. Specify where you want to go and save it. I've got the file. I'll import it into our newer project at a later stage. That is the survey information sorted. Now we've got to make provision for the CAD drawing. So I want to remove this CAD drawing from the rest of the project and then just treat it as a CAD drawing. I do so by going to File, Project Settings again. And instead of switching these modules off individually, I can go and select Reset Project. Click on OK. I don't need to keep the water entities in this case. I'm going to say no. And then I'm going to save it as the drawing. Go to File, Save As, and then save it just as the drawing file. I don't need to save the terrain file, so I'm going to click on Cancel and then close this. While we edit, I'm going to close this project and open it up at a later stage. If I open up just that drawing, Civil Designer says it can't find the DTM. Do you want to locate it yourself? I'm going to click on No. And that is then just the CAD drawing. We can also utilize that for the newer project that we are going to create. Please bear in mind, if we go to Windows Explorer here, and we go to where our project is situated, and then switch on just the DT8 files. Now, if you recall, when I started with this, I've said that the roads are associated with the terrain file, but we are going to import new terrain data. So what I'm going to do here is delete this and create a new one. And this is so that we don't have to rename all 35 roads. Closing that, closing the drawing, and then creating a new project. As you normally would, we go to File, Project Settings, create the new terrain file. So this is the one that I've just deleted because I want to bring in new information. And then set up my projection settings correctly. And once all of this is done, we can then export it into Google Earth again for verification. If you're not quite sure of which projection settings to use, it is a good idea to consult the surveyor on site. We also give you the option as presets. Don't forget that if you're looking for something particular, you can go and specify where in the world your project is situated. Alternatively, if you're looking for a particular country, you can go and select it. This is set up for Gauteng regions. I've set up the central longitude correctly. Click on OK. If you do get this option that there's an existing terrain work file found, you can click on No to reuse the file and recover the data. But we then bring in new information. So we've got the project, but we need to import the surveyed information now with the correct projection settings. So we go to File, Import, ASCII YXZ, single file, select the one we've just created. It's a comma delimited file, click on Next. My columns are already named correctly, but if need be, you can go and change that and then go and save the settings as default. It may be a good idea just to check that the rest of these columns are named correctly. Click on Finish. Check in that your coordinates are correct. Click on Yes to continue the import. So we've got all the DTM or all the surfaces. They are now in the correct place. You can then go back to File, Project Settings, and then bring back the different modules. So bringing back the sewer information. Remember, we renamed it as number 1 there. Same thing applies to the stormwater and the water. Not forgetting the roads. So if we go back to our display settings there, and then switch on to display roads. Click on OK. Zooming into the project. Maybe a good idea then to go and turn off your triangulation or your points. But looking at the roads and the different services are all there correctly. Let's not forget about our CAD drawing that we want to bring back. So we go to our CAD mode, go to File, Load, Load Drawing, and then use that drawing that we've just created as well. If you want to now pick up on yourself, you can then export that again to Google Earth. So I'm going to export to a KML file, click on OK, specify again the KML file position. And if we go back into Google Earth, I'm going to reload the file. So again, from the desert to the correct georeference position. Always nice to see the confirmation in the correct spot. That was our first example. Let's close Google Earth for now. Back inside Civil Designer, we then move on to the next project. You can save this as something else if you wanted to, and go through the save process again. Moving on to the next project, where we set up the projection settings to have a local projection setting. This one is a little more detailed in that when we move it to the correct geo-reference position, we find that the rotation and the scale of the project isn't correct. I'm going to show you some additional tools that you can utilize to correct this. Looking at the current projection settings, I'm going to go to File, Project Settings, picking up that it's set up for local projection setting. So we don't quite know where in the world our project is situated at the moment. And what makes it worse is this drawing doesn't have any coordinate grid files. We really take in raw CAD data and utilizing it as best we can to georeference it. Click on OK. The next step is to export this into Google Earth so we can get some kind of idea as to where it's positioned. Before I do that, some things I want to point out. If we look over here, this is Korea Boom Avenue. And after doing a bit of Googling and finding the correct position, I found that this project is based in Cape Town. Zooming out, I've got 3 reference points or benchmarks that we're going to work with. And this is for reference. So I've got benchmark number 1 there. I've put in number 2 over there. And then on the northern side, I've got number 3. Remember those, we'll utilize them quite extensively at a later stage. Getting some sort of idea as to where we are at the moment, I'm going to export this again into Google Earth. Because we've got a projection settings of local, if I try and export this into Google Earth, I get a warning here that I can only export the CAD entities. I'm happy with that. I need something to work with. And then, as I mentioned, after a bit of research, we found that the project is set up in Western Cape. So the central longitude there would be 19 degrees east. Click on OK, and then specify where you want to export this KML file to. Remember, I closed Google Earth, so it's going to reopen it. And looking at the position of our project, it's very close to the equator. Bearing in mind that we're looking for a street called Korea Boom in the Western Cape. So I'm going to go and search here for Korea Boom Avenue. And we're looking at Hales River, Cape Town. Before I go and select search, I want to get an idea as to how far the current drawing is to the correct geo-reference position. So I'm going to select a point on Koreaboom Avenue, and then I'm going to go and select search. Looking at my distance and my heading gives me a good idea as to where the project should actually be positioned. We are looking close to 3,733 kilometers. Happy with that. I'm going to go and close that measure dialog. Just zooming out a bit, ensuring that I've got the full extent of my project. From here, I can already see that our project is going to need a bit of rotation. Ideally, you want to go to View, Reset, and select Tilt and Compass, but I'll do that at a later stage when we do get the error message. Back inside Civil Designer, we'll come back here later. Remember that we have to create a new project in order to import the correct surveyed information in the correct central longitude with the correct projection settings. I'm going to do this by going to File, Export, ASCII. Like we did before, click on Next. I'm going to accept the defaults and click on Finish. Specify where you want to go and save it. And then once again, I want to utilize this drawing in our new project. Like we did before, again, I'm going back to File, Project Settings, and I'm going to reset the project. Just so that we can work with only the drawing, and select File, Save As. I'm not going to save any DTM information. Close that, and then go back to File, New, File, Project Settings. Create a new terrain file. Let's call this corrected number 1 again. And ensuring that I've set up my projection settings correctly. Click on OK. In this case, we didn't have to save our project as something else because this project doesn't have any roads associated to it. Now that we've got the correct projection settings, we can import the survey again. Do this by going to File, Import, ASCII YXZ, single file, using the exported information, and then just checking that we got the correct information over here. If you do make changes here, you can always save the settings as defaults. Only working with surface number 1. Now we've got the survey. Perhaps we should bring in the drawing as well. Go into our CAD mode. No need to export to any other software. Go to File, Load, Load Drawing, and then just bring in the drawing. If you zoom in here and I turn on my names, there's the 3 benchmarks that are pointed out with the red circles. If you export this into Google Earth, you'll still find that the project isn't in the correct space. We still need to go and move it, and we need some sort of indication as where to move it to. I'm going to take a snapshot of what's in Google Earth just to show you what we've got there. And then I'm going to import that into Civil Designer so that we can geo-reference this information accordingly. Inside our CAD mode, we go to Tools, External Utilities, and we take the Google Earth snapshot. Click on OK. Specify where you'd like to go and save it. And click on OK. We might get an error message here. This is the error message that I pointed out earlier. I didn't correct it back then because I thought we'd benefit from it more if I did it now. I'm going back into Google Earth. I'm going to View and I'm selecting Reset, Tilt and Compass. This is just for more accuracy. Back inside Civil Designer, we go back to Tools, External Utilities again, select Google Earth Snapshot, click on OK. Specify again where you want to go and save it. Check in that your projection settings information is correct and click on OK. By default, a monochrome image will be saved. If you're happy with that, you simply insert it now. Alternatively, you can override the monochrome with color. And then you do that back inside Google Earth. We go to File, Save, Save Image, specify what you'd like to save, and then click on Save Image. Override the previous monochrome image. Returning to Civil Designer, and then insert that image so that we know where the correct georeference position is. I go to Insert and select Image. Select the image. Confirmation that we really need at this stage. The image has been placed in the drawing according to the information in the associated georeferencing file. Click on OK. If I pressed ZA for Zoom All, where you see the X, that is where our project is situated. And if you look at the bottom here, this is where our image is positioned. Just to select it, press Z on my keyboard and then S for selected. And if you recall, I actually measured the distance between our survey and this position, and we're looking at 3,733 kilometers. Next up in this phase, we want to bring our drawing and our survey to the corrected georeferenced image position. And then press ZA again, and then you select the drawing, and then again zoom selected. It would have helped if we had grids on our drawing with coordinates. In this case, we don't. So what I'm going to do is I'm simply going to select the drawing and then move it. I've selected it, so I go to Modify, Move, and then zoom into that benchmark that we'll use, and then press J on my keyboard as a shortcut key, Enter. Reading my prompt, it says indicate the destination point. Again, zoom all on my keyboard. Zoom into the position of the image. You could use your viewport here if you found that you'd benefit from that. And then using the calibrated eyeball method, go and specify where you want this point to be. Now, unfortunately, in a situation like this, you're never going to be 100% accurate, but it's a lot more closer than 3,733 kilometers. If I were to zoom out, we find that we need to now rotate our drawing. Again, we go to Modify, select Rotate 2D. Reading the prompt again, indicate the point about which to rotate. My last fixed point is still there, so I can press X on my keyboard, Enter. And then reading my prompt again, it says indicate point that must rotate. I'm going to the furthest CAD point here, and then press J, Enter, and then just manually move that to where I am happy with the rotation. I've just shown you how to move the drawing, how to rotate the drawing. Now we need to scale the drawing. We actually need to move, not sure if you can see that on the screen, we need to move this point up to this corner. I go to Modify, select Scale, indicate point about which to scale. I'm going to return to our benchmark number 1. Place my cursor close by, press J, Enter. Indicate point to be scaled. Going to the furthest point from our benchmark. Same thing here, press J, Enter. Now I'm using a lot of keyboard shortcuts, but of course you can also use your snap modes positioned on the right of my screen. and then left clicking. Press escape. If I select my bitmap and zoom in, you can see the position of our drawing. I'm done with the drawing now. I have the option to go and change the fade of my bitmap or image, or alternatively I can just turn it off and then utilize it or turn it on at a later stage. In this case, I'm then going to create a layer for it. So I'm going to add a layer called image. Now I'm going to turn off that layer, click on OK. With it still selected, I can go to modify, move to layer, and let's put it on the layer called image. At this stage, we've moved our drawing, we've rotated the drawing, and we've scaled the drawing. Now we need to do the same for the surveyed information. You could straight away go to your survey mode, select transformations and group. But I want to show you some more design features. So first of all, I'm going to rescale the survey. I'm going to give it a different coordinate set, and then we'll come to this transformations functionality. Some of our clients find it beneficial to go and put in a big geometry cross over here so that you've got something to geo-reference to. So if I go and press ZA again, you can see the position of our drawing as opposed to the position of our survey, which is still up here. I'm going to press ZW for zoom window and then just zoom into the position of our survey. I'm still going to revert to this benchmark number 1. As mentioned, let's first rescale our survey and give it a different coordinate. Taking a look at this rescale function, if I go to the terrain mode, I go to tools, rescale survey, we need to go and specify constants. But at this stage, we don't know what the constants are. But first, before we do that, and then you zoom last, we're going to pick up the existing survey coordinates. We'll pick up the new drawing coordinates and then apply those constants. I'm going to go to survey mode, go to listing. There's different options here. I'm going to go and select indicate. Okay. Specify where you want the result. So if you want to create an ASCII file of the result, you can do so over here. Click on OK. And then placing my cursor close to my DTM point, if I want to be sure I'm jumping to that DTM point, I can use my keyboard shortcuts by pressing Shift and the letter D. It then jumps to my surveyed point, and then you right click and quit. Looking at the additional options, you can go and specify a particular output. I'm going to close it. We're done with it for now. If I then go and move my output bar at the bottom, you can see BM, benchmark number 1's coordinates, which we'll utilize shortly. Pressing ZA again, I'm going to select what we've got in the drawing, and then again press zoom selected, escape. Zoom into our benchmark number 1 and get the coordinates of our 3 benchmarks. Because it's a CAD drawing, I'm going to the CAD mode, I'm going to dimension. Again, different options. So if you, for instance, wanted to select label chords, you could do so. As you're moving your cursor, you can see the coordinates update. In my case, I want to go back to dimension and select the coordinate table. This one is eventually going to be called benchmark 1A. Specify YX coordinates and click on OK. Reading my prompt, it says indicate point to add to table. Placing my cursor close by, pressing J, not moving my mouse, enter. Confirmation, we're happy with the label text, click on the green tick. Moving on to the next point, we'll head south. Place my cursor close by, press J, enter again. Specifying the new name, and then heading north again. we're going to use these 3 points for the transformation. Done with those 3 points, reading my prompt, I can right click and select finish. I do have the option to export this table as a text file. I'm going to click on OK and then specify where I want this table to be. Zooming in, taking a look at the coordinates. Now we can revisit that function. We go back to the terrain mode. We go to Tools and Rescale Survey. Apply constants. And with the information we've just gained, we can now go and give a constant value. Instead of using my calculator, I'm going to ask Windows for calculator. There it is. Let's punch in these Y values. Looking at 288.30.631 minus this Y value over here, 76,279,794 equals. And then you copy this information, and I'm going to right click and paste it over here. Just be careful if you do use that calculator to get rid of any spaces and replace the comma with a dot. Returning back to the calculator, put in the X value this time. Same thing as before. Select this, right click, copy, go over here, right click, paste, get rid of the spaces, replace the comma with the dot. Just click elsewhere so that you've got confirmation that you've inserted the correct constants. When I click on OK here, the survey that was very far north would have moved closer to the position of our drawing. Having done that, if I press ZA for zoom all, you can see everything centralized in the correct position. So we get in there, just a couple more steps. We still need to rotate and to scale the survey. Now, you may be thinking you could probably use the Google Earth Grid functionality for this, but remember that that is really just for preliminary project purposes, for conceptual design, whereas this survey may be more precise. So I want to go and rotate the survey and scale it. I'll do it at the same time. We could probably go and turn off the geometry for now. So I'm going to my CAD mode and switching off the geometry. Back in the survey mode, this is the function I pointed out a bit earlier. We go to transformations group, but I want to be able to see my coordinates. Then we go back to group over there, click on OK. You want to use your own transformation parameters. I'm going to select no. The old system, we're looking at those benchmarks again that I pointed out. When we create this new system, I'll call it benchmark 1A. And I'll utilize these coordinates over here. I'm going to select add. Civil Designer picks up the old system coordinates, which we already have, but now it's asking for information of the new system. So I'm going to input these coordinates. Maybe a good idea just to check up on yourself and ensure you've inserted the correct coordinates. Click on OK. Moving on to the next point. Final point. Click on OK. You would need a minimum of 3 points. The more points you have, the more accurate the result would be. And then just some information over here looking at the scale factor, the swing, and the percentage. The percentage is the difference between your old and your new system. Click on OK. OK again. You do have the option to save this transformation primitive. I'm not going to do it again in this case, so I'm going to select no. Civil Designer will now automatically go and create a new ASCII file with this new surveyed information, so that if you ever need to revert back to the original information, we haven't overridden the original information. So when it creates this new ASCII file, you can then go and filter it out and specify that you only, for instance, want specific names or surfaces, etc. Click on OK. Specify where you want to create this new file. In your output bar at the bottom, you can see the new file has been created. I'm going to import that file, but before we do that, let's see if I can go and turn off surface number 1. Going back to File, Import ASCII, single file, selecting the transformed surface, specifying that it's a comma delimited, and then as per usual, just check that you've got the correct information here. I'm going to go and ignore that column and then rename the different lines. Click on Finish. Take note of your new coordinates and click on Yes to continue with import. And then bring it in on a different surface so I don't overwrite surface number 1. With this new surface, you can see that we've changed the rotation as well as the scale of the last surface. For confirmation purposes, if need be, you can then export this back into Google Earth. I think my time is up. Thank you very much for joining me. If you do require any additional information, please do let us know. Until next time, cheers for now, and back to you, Charles.
Thank you very much, Cameron. That was once again excellent. If you enjoyed today's webinar, please visit our website where, under the services menu, on the webinars page, you'll find a list of our last 85 webinars. And by later this afternoon, we would have posted a link to a copy of today's event. While here, please visit our FAQ library page, where we have posted over 500 short, searchable videos created from our webinar series. This page has become an extremely popular online support resource. Once again, thank you very much for allowing the time to join us today. Please follow our company page on LinkedIn if you have not done so already, where we post our latest customers' civil designer project showcase stories, relevant industry news, and new civil designer tech tip videos. Please have a great afternoon, weekend when it arrives, and goodbye for now.